Welcome to today's class. Before we go right into a topic, I would like to ask a question, which is, have you ever thought why your camphor disappears after a while? Regardless of the color or the shape it comes in, you just discover that after a while, you stop seeing them or they have been reduced. So why? What is the principle behind this? This will lead us to our class today on matter. And by the end of today's class, you should be able to define matter, know what it is, recognize that all living and non-living things are made up of matter. That means they are matter, and you should be able to identify matters and place them in their states. So once again, our topic is matter. And the funniest part is matter is everywhere. If you look around you, in front of you, behind you, at your right hand, your left, just check everywhere. Anything you can see around you is matter. So everything around you, regardless of their states, whether they're solid, they're liquid or gas, the plant, the rock, animals, the air, anything you can think about that is around you, they are all matter. Whether you can touch them, feel them, or you can taste them, they are all matter. So what is matter? Matter is anything that has mass and takes up space. Anything whatsoever that has mass and takes up space is matter. So we can say that again. Matter is anything that has mass and takes up space. Can you say it one more time with me? Matter is anything that has mass and takes up space. So we have classification of matter. We can classify matter into two major categories. One, you can either classify matter into living and non-living, or that is living and non-living things, and you can also classify them by their states. I will just give you a brief explanation of the living and non-living things. For example, non-living things, when we talk about non-living things, these are things that do not have life in them. That means they cannot grow, they cannot respire, they don't eat, so they don't die. Those are non-living things. And from our slide, you can see that we have the book here. It's non-living. You can see the rock, the chair, anything you can see that is non-living, that is not breathing, that does not reproduce, they are all non-living things. Whereas for the living things are the things that have life in them. From the picture, you can see the kids are running, you can see the elephant, you can see the plants, it's moving. So it shows that they are living, they are responding to stimuli, they are breathing, they can grow, they can eat. So they are all living things. So as I earlier said, matter, we have categorized matter into living and non-living things. Now the other category, which is the state of matter. So you can either categorize matter into solid, liquid, or gas. Anything you can see, wherever you can see them, they can be categorized into these three states: solid, liquid, and gas. They can be categorized into what? Solid, liquid, and gas. So very quickly, we'll go into a solid. So you can see these pictures. You can see the rock, it's solid. You can see the table and the chair, the clothes, the cups, the spoon. You can see the brick too, the doors and the window, they are all solid. Even yourself, you're solid. Touch yourself, you can feel yourself, right? You are solid. You can feel the people around you, you can feel your clothes, you can feel your skin, you can feel everything. That is what those things are. Those things you can feel, you can touch, they are solid. So what are the characteristics of solid? Whenever you see solid, how do you know that these are solid? One is they are relatively rigid. They are rigid, they are hard. Just like your skin, just touch yourself, you see that you can feel something, yes. So they are relatively rigid, they are hard. Then they have a definite volume and shape. In this example from the slide before, in the picture that we had, you can see the stone, it has a particular shape. You can see the stone, it has a particular shape. So they are relatively, they don't have a volume, but they have a specific shape, a specific volume, I mean to say. They have specific volume, they have a specific shape, and they have a definite mass. That is for your solid. That is number 2. They have what? Number 1 is they're relatively rigid. Number 2, they have a definite volume and shape. Number 3 is they are not easily compressible. That means you can squeeze them into a corner. Let me put it that way. Yes, you can't squeeze them, you can't compress them, you can't easily reduce them, not easily compressible. For you to reduce a mountain, you have to break them into pieces. So they are not easily compressible. They do not flow easily. Have you seen rock flow? I don't know, have you ever come across a rock that is flowing before, or a table that is flowing, or a chair that is flowing? Except in cases of flood, you don't see them flow. They don't flow. They do not flow easily. Number 5, the atoms and molecules are attached to each other, and that explains the reason they are explains the reason for their rigidness. The atoms and molecules, they are attached to each other. Number 6, particles cannot move, slide past one another. Their particles cannot move, slide one another. They are static. Then they have, the last and not the least, they have little free space between particles. So those are the characteristics that make solid. So whenever you come across any solid, you must notice that they are rigid, they have a definite volume and shape, such as your cup or your table. You will know this is rectangular, your table is rectangular, it's either rectangular or in a square form. Your chair, your book, your pen, they have a specific shape, and you can compress them. If you try to compress your pencil, for example, you have to break it for you to be able to compress it, and they don't flow easily. The atoms and molecules are attached to each other. So we'll move to the next state of matter, which is liquid. From our diagram, you can see a waterfall, and you see how it's flowing. So it shows that, in contradiction to solid, they flow easily. They have definite volume, but they're able to change shape by flowing. When you come across water, they have definite volume, for example, which is an example of liquid. They have definite volume and they flow easily, and the shape changes with the container it bears. If you have your water, which is a good example of liquid, and you put it in a cup, it will take the shape of that cup. If you put it in a bottle, it will take the shape of that bottle. It will also take the volume. Water does not have a specific volume, so it is streamlined to the container you are putting it. So your container determines the volume of that liquid. Whatever it contains, that is the volume. So if you have a 25 liters bottle and you add either your tea, which is an example of liquid, or you add your juice, which is an example of liquid, or your water inside, so your juice the juice you're going to have inside that bottle will be 25 liters, because the bottle can only take 25 liters. So another thing, number 2, is it assumes the shape of the part of the container which it occupies. If you have a bottle that is maybe a particular bottle that is demarcated, and you have something barricading it in between, and you decide to pour water or your juice or your tea in one part of the bottle, it's going to take that particular space. If there's no leakage or there's no passage for the water, it won't flow into the next. So it only assumes the shape of the part of the container which it occupies, and it's not compressible. You cannot compress liquid. You can't compress them. They will always look for a way to go out. Because they flow easily, and the reason why they flow easily is because the atoms and molecules are loosely banded. Their atoms and molecules, they are loosely banded, so it's easy for them to flow. Another characteristic of liquid is the particles can move, slide past one another. They can either move or slide past one another. Unlike the solid cannot easily move. It's rare before you see solid, but from liquid they can move past one another. That explains the reason they flow. So number 7 is they have little free space between particles, little free space between particles. So as I earlier said, for the liquid, you can see their characteristics over here. So anytime you come across liquid, you check any matter you come across and you want to be sure if it's liquid or not. You check, does it flow? Yes. Does it take the volume of the container? Yes. Does it take the shape of the container? Yes. Are they easily compressible? No. Are they compressible? No. The atoms and molecules are they loosely bonded? Yes. So you know that this is liquid. So we'll move to the next state of matter, which is gas. Gas. So what are the characteristics of gas? Number one is it have no definite volume or shape. Just like the liquid we talk about, it have no definite volume or shape. So it takes up the volume of the container in which it is and the shape of the container in which it is. You can see a man in the picture with a fire extinguisher try to put off fire, right? And you can see that the gas is coming out from the fire extinguisher. This explains that the cylinder, the volume of the cylinder is same as the volume of the gas. So whatever the cylinder can take, whatever volume the cylinder can take, that is what the gas also will be. Same with the shape. So it assumes the shape and volume of its container, and it is compressible. Unlike water and solid, you cannot compress solid. Solid are not easily compressible, as I made allusion to pencil and the stone the other time. You have to break them for them to be compressible. And for water, you cannot easily compress them. They will have to flow out. But for gas, you can easily compress them. They are compressible. And they flow easily. Gas flow easily. The atoms and molecules are loosely bounded. The atoms and molecules of gas are loosely bounded. Then the particles can move past one another. Just like we have in liquid. The particles can move past one another. Then there's lots of free space between particles, and that explains why it is compressible. Those spaces, you can compress them to have more gas in them. They have lots of free space between particles. So we have looked at the state of matter, and we've seen them we categorize them into solid, liquid, and gas. Solid, liquid, and gas. And we can see that for solid, you cannot easily compress them, and they are rigid. For solid, they have a definite volume and shape. But for liquid takes up the volume and shape of whatever container it is. It takes up the volume and shape of whatever container it is, and it is not easily compressible. You can't compress it easily. Water will just look for a way to flow. Anywhere you put it, it wants to flow, it wants to move, except you restrict it. Even in the restriction, it still wants to flow, so you cannot easily compress them. But for gas is easily compressible. You can compress it into whatever container you want to compress it, and they flow easily. And just like liquid, they take up the volume and shape of the container. So now the next question is, can these various states, can they change their states? Like, is it possible for them to move from one state to another? Is it possible for solid to move to liquid and liquid to gas? Is it possible for gas to move to liquid and liquid to solid? Is it possible for a liquid substance to be changed to gas? We are going to look at it. It is important to understand that matter exists in all states, and that matter can also change states. Every matter you see can change states. It does this by either using or releasing energy. It is usually associated with changes in temperature and pressure. So when you change the temperature of a solid, it can change to gas. But this change I'm talking about does not affect the chemical properties. That's why I'm just strictly talking about the physical change. It is the physical change. So physical transition includes the conversion of a material from one state of matter to another without changing its chemical composition. So you can change a matter from solid to liquid without necessarily changing its chemical composition. So it's just a temporary change. We have permanent change. This when you have this when it involves the you are changing its chemical composition. That means it cannot be reversed to its original state. So let's look at some of this. A sample of this is water. We're going to be using water for our illustration. So if you have a block of ice, you have solid water. That is what you would do. You have a block of ice, freeze is very chill, very cold and hard. You have a block of ice, you have a solid water. So what do you do to change its state? You add heat. Heat is a form of energy. And the ice melts. The ice, that the block of water you have, will melt into a liquid. So you have changed it from its solid state to a liquid state. So you can use this water either for drinking, to wash your clothes, to do your dishes, and whatever you want to use it for. So you now have your liquid water. So, and this at the point at which your block melts into the ice, into the water, we have something that we call the melting point. That is the melting point at which your ice block melts into a water. So if you continue to apply it, the water will get to a state in which it will start to evaporate. It will boil and will start to evaporate and turn into steam, which is the water. Which water is in its, we can say that now that water is in its gaseous state. It has reached the boiling point. So the point at which the water changed from the liquid to gas is boiling point. The first one we talked about was the melting point. That was the point at which an ice block or a block changed from that block state, that ice state, and melts into liquid. So that point is melting point. Now when it changes from liquid to gas, at the point at which it happens, it is the boiling point. And you can also go backward. This works backwards too. So your gas can cool down by losing energy and condense back into liquid water. You're going to see this in all illustration. I just want to explain this, then we'll go into illustration. So your gas can cool down and condense back into liquid water. And if it cools further, you will have your solid back. So there is even a process by which we call sublimation. I asked a question that how, if you remember, at the introduction, at the beginning of this class, I asked that, why do you think your camphor suddenly disappears? Have you ever thought about it, or you just see that it's reduced? The process by which that camphor changes from solid to gas is called sublimation. So you don't need, the camphor does not need to go through solid to liquid, like in the case of this block that I talk about. No, it just goes straight from solid to gas. And it's not only camphor that can exist in this state. We also have your iodine crystal. They can change directly from solid to gas. You can see that it's very possible now for you to have your solid change directly into gas. So this process is called what? Sublimation. So look at it. Look at this graph we have here. You have your temperature and you have energy. So, and I said, if you notice when I was reading it previously, when I was teaching previously, I told you that they can change into one state to another by either gaining energy or losing energy. The blue line you are seeing there is solid. It is solid, for example, as in your ice block, your block. So when it gets to its melting state, you can see the melting in yellow. So it melts into liquid. And you have your liquid in green. And when it gets to its boiling state, you continue to apply it to it, begin to gain more, it changes to what? To your gas, which you see in red. And when through the reverse process, you want to take back your gas to liquid, and from your liquid to solid, you have from gas to liquid, we call it condensation. That is the process. That is condensing. I mean to say condensing. So you have your gas to liquid through condensation. Your gas to liquid occurs through condensation, and your liquid to gas, your liquid to solid, I mean to say, occurs through freezing. So let's look at this illustration. You can see solid to liquid melting. You can see this solid is suddenly changed to liquid, and you can see a fire underneath to show that there's a heat that was applied to facilitate the process from solid to liquid. And the second diagram, you can see from solid to gas, which I told you about, that it is sublimation. For example, your camphor, everybody should be familiar with it. Your camphor, you just put it in your box and suddenly discover that it has disappeared. So from solid to gas, you have sublimation. You can see that solid and suddenly it changes to gas. That is sublime through the process called sublimation. And in this diagram, you can see liquid to solid. From liquid is like your water, your liquid water. And an example I'm going to use here is if you have your freezer, you can just put water in a container and just put it there in the freezer and allow it to freeze. You discover that your liquid water will suddenly, by the time you go back there after some time, you see that it's become an ice. So, and the process through which it's passed through is freezing from liquid to solid. The next diagram you can see there is from liquid to gas. From liquid to gas. From the explanation I made earlier on, I told you that when you continue to add it to that your water, you discover that it gets to a point which we call the boiling point, and it turns to gas. The process is called vaporization. Process by which your liquid changes to gas is vaporization. So, and you can see from gas to liquid, your gas to liquid. These are things you can even carry out, experiments you can carry out in your homes, but you should be guided by an adult. I must say this. For example, for your gas now, if you're boiling water, so you can have that your water started boiling, your liquid, and started boiling. At the boiling point, you see something like smoke coming out. That is your gas. So just take a container, perhaps an iron container, and just place it over that steam that you can see coming out. You discover that you begin to see some formation of vapor on that lid you are holding, on the whatever container you're holding. And if you allow it to cool down, you have your water back. That is condensation. So your gas to liquid is condensation. And for gas to solid, we call it sublimation. From your gas to solid, from gas turning to solid, don't forget that solid to gas is sublimation, while for gas to solid is called reverse sublimation or deposition. You can either call it reverse sublimation or deposition. So it's possible for your gas to go back to solid, just the way you have solid to gas. It's called reverse sublimation or deposition. You can see in the diagram above, you can see the gas forming under that container, and you can see it is solid. An example that I'm going to give you is soot. If you live in an environment with soot, you don't see soot. But after a while, when you touch either your table or your chair or the wall, you see some black substance in your hand. That is soot. Those are solid material. Those are solid. It has turned to solid, from gas to solid. So the one you're seeing there, the illustration you're seeing there, is iodine crystal, from gas to solid. So I believe you've learned a lot from today's lesson. We started from matter, and you know what matter is: anything that occupies space, anything that takes up space and has mass. That is matter. And we now look at the various categories of matter. You can categorize them into two: either non-living and living, and you can either categorize it under the states, that is solid, liquid, and gas. And we have also looked at we've also looked at it that okay, we can change the states of matter. Can be changed. That means you can change from solid to liquid and liquid to gas. You can change from gas to liquid and liquid to solid. Your solid can be converted to gas directly through the process called sublimation. Your gas can be converted directly to your solid through the process of reverse sublimation or deposition. And your liquid can change to solid through freezing. your liquid can be changed back to solid through freeze. That means you just reduce the temperature and you have it all back in block, that is in the solid form. And your liquid can change to gas through vaporization. I mean to say vaporization. So we want to look at some questions using the exam guide. I want to look at some questions in the ExamGuide app. So when you get to this app, you click on the subject, which is basic science. You click on the subject and you click on the year. This, I'm going to be using a random year just to pick some questions and see what we can do with them. And also you select your topic of interest, which is change of state of matter, or you change of state of matter. So when you click on them, you get started. So let's look at some questions together. So I have a question here, and the process by which ice block changes to water is known as. The process by which ice block changes to water is known as. First, you have to check the state of the matters we're talking about here. One is ice block, and ice block is what? Solid. So we have one solid. So, and changes to water. Water exists in its free state as liquid. So we are changing from solid to liquid. The process by which a solid is converted into a liquid is known as. We have A, boiling, B, condensing, C, cooling, D, freezing, E, melting. So the process by which solid changes into a liquid is what? Melting. So we have E. So you click on E. That is the answer, melting. True words, when it gets to the melting point, when you apply your heat to your solid and it gets to its melting point, it changes to liquid. So the process by which ice block changes to water is known as melting. Let's check for another question. So in this question, we have this. The process, this is the direct question. The process by which solid changes to liquid is. This is a direct question. You don't need to start, okay, is this one solid or liquid? It's direct, solid to liquid. We have A, condensation. We have B, evaporation. We have C, freezing. We have D, melting. And E, sublimation. Condensation cannot be the answer because it's from what? Gas to liquid. We're looking at solid to liquid. When you have condensation is when you're converting your gas to liquid. We have evaporation. This cannot be the answer because you have evaporation when you're converting your liquid to gas. I talked about vaporization, yes, from your liquid to gas. We also have freezing. No, freezing cannot be the answer. Freezing occur, solid changes, freezing occur when you have your liquid to solid. So freezing definitely cannot be the answer. And I have D, melting. Okay, let's check. Is it melting? Solid changes to liquid. It is what? True melting. And E, we have sublimation. So it's definitely not sublimation because sublimation occurs when you have your solid changing to gas. So the answer is D, melting. Melting. Let's check for another question. So we have another question here, and it reads, the process by which solid changes directly to gas is. If you were very attentive at the beginning of this class, I mentioned something like camphor. Why does it disappear all of a sudden and you just stop seeing them? This is just the question here. The process by which solid changes directly to gas is A, we have condensation, B, we have evaporation, C, freezing, D, melting, and E, sublimation. Let's go through each of the options. We have option A, condensation. Condensation, when do you have condensation? That is when you're converting from gas to liquid. That is condensation. So definitely it is not condensation. And B, you have evaporation. When do you have evaporation? When you are converting from liquid to gas through vaporization. So it's not the answer. We have C, option C, freezing. No. When do we have freezing? When you're converting from liquid to solid, you have your freezing. So it's not the answer. We have D, melting. When do you have melt? When you're converting from solid to liquid. So it is not option D. And the last option is E, sublimation, and that is the correct answer. That the conversion of your solid directly to gas. That means it's not passing through liquid. It's not, you're not changing from solid to liquid to gas. It's directly from solid to gas, and it is through the process called sublimation. Through the process called sublimation. And I know you've gained a lot from this class. You can do more of this on ExamGuide app and check out for more questions in regards to our lesson. Thank you.